We're given a quadratic function f of x, and we are to determine each of the following things and round any of our answers that exist to the nearest hundredth and any that do not exist as dne. The first question is, does the graph open upward or downward? And I am to circle one. It turns out, since my a value here is -3, when I say a value, let me write down a quadratic in general. A quadratic equation is an equation that can be written as some number a times x squared plus some number b times x plus some number c. My problem is f of x equals -3x squared plus 6x plus 11. It turns out that our a value is -3. So it turns out if that's negative, which it is in this case, your graph would open downward, and you can see that I gave a sketch of the graph over here. So I'm going to say the graph opens downward. Had that been a positive number, it would open upward and look like the letter U of the alphabet as opposed to an upside down U. The next question says, what is the vertical intercept? A vertical intercept is where the graph crosses the vertical axis, and that would be what you get out when you plug in 0. It looks like it's around 11, and in fact if you plug in 0, everything simplifies out very cleanly. Let me replace this x with 0 and this x with 0. And you can see just by looking at this, because anything multiplied by 0 is 0, this would be 0, this would be 0. So we get f of 0 is equal to 11. So we got that the vertical intercept is, if you plug in 0, you get out 11. For the horizontal intercept, it's the output that is 0, and I am trying to find the input. So for this problem, you would take the output variable and you would set it equal to 0, and then I'm going to use my intersect feature on my graphing calculator to find out where the curve right here intersects the line y equals 0. So when I put in y equals 0 on my calculator, it's going to be graphing the horizontal line through 0. That'll be my second equation. And as a first equation, my y sub 1, it'll be this side of the equation, the -3x squared plus 6x plus 11. So let me hit y equals, I'm going to type in -3x squared plus 6x and then plus 11. Hit the down arrow or press enter and make sure you type in 0 for the second equation. If you don't type in y equals 0, you'll only be giving the calculator one equation and there would be no intersection then. So I'm going to press zoom 6 and hope that this shows up roughly on a standard window. I'm pretty sure I'm not going to see how high the graph goes, but I should at least see where the graph crosses the line y equals 0. And my calculator being color-coded, you can actually see the line y equals 0 being graphed. So to do this, I'm just going to press second, trace to access the calc menu, press 5 for the intersect feature, press enter to say that this is the first curve in question, and then press enter again to answer this second curve prompt saying that that's the second curve in question. Then it wants me to guess. Since I want the one on the left first, I'm going to go to the left and get close to that area, but press enter, otherwise you're just guessing. If I press enter, I will get an answer to several decimal places. I was to round to the nearest hundredth as necessary, so I get -1.16. -1.16 is my leftmost intersection point. Then to get the right one, go back to your calculator, press second trace again, repeat the process by pressing 5, and then that's my first curve, enter, and then press enter a second time to say that that's the second curve. If I press enter here, because my guess is over here, I will get the same answer I got before. So you need to hold that right arrow key down. It's actually faster if you press the second key and then right. As long as you're closer to this intersection than that one, you press enter for the guess. Make sure that it doesn't say guess. Actually press enter and get the word intersection. And to 2 decimal places, the hundredths place would be 3.16. So 3.16 is another x value that would give me an output of 0. And now I'll move on to the next question, which is the vertex. The vertex is the highest point on the parabola. Had our graph opened upward, the vertex would be the lowest point of the parabola. So for this one, I'm going to find the vertex using the formula for the vertex of a parabola. Now it turns out there's a formula for both the x and the y coordinates, but the formula for the y coordinate is sort of messy, and I usually don't memorize that. After we get the x value that we need, we can simply plug it into the original equation and get the y value. So in general, the vertex of a parabola, at least the x value I should say, would be found by doing -b over 2a. or you can think of it as the opposite of b divided by 2a. So my b in this problem is 6, so opposite of 6, and then you are to divide by 2 times a, and in our problem a was negative 3. This would simplify to b. Negative 3 times 2 is negative 6. Negative 6 divided by negative 6 is simply 1. So that is just the x-coordinate of the vertex. We get x equals 1 is the x value of the vertex. To get the y value, you could simply plug it into the original equation, and that would look like this. You'd replace every x value in the equation with 1. Doing so carefully and then simplifying, I will get the output corresponding to an input of 1. So I get that f of 1 is 1 squared is 1, 1 times negative 3 is negative 3, 6 times 1 is 6, and then you still have the plus 11 over there. And then what we have here is 11 plus 6 is 17. 17 minus 3 is 14. So to summarize, we plugged 1 in and we got out 14. And that gives me the y-coordinate of the vertex. And you saw that all along that we have a vertex here of 1, 14. So we got that the vertex was 1, 14. And we can move on to the next question, which is the axis of symmetry. This is basically saying that if you were to look at a parabola, that there's some symmetry involved. In fact, if you were to look to the right of this vertical line, sometimes we say if we reflected the curve about that line, that the image over here would reflect over there. Sometimes I tell students what this would look like is if you were a kindergartner and you put finger paint on a piece of paper like this right here, and you fold it about the blue line, that paint would fold over and give you this. Meaning that this is a mirror image of that, and it would only be a mirror image if you folded the piece of paper about that line. So the question here is, what is that line? What's the equation of the vertical line that passes through x equals 1? And I basically just answered it. X equals 1 is the line of symmetry, and whenever you graph an equation of the form x equals a number, you get a vertical line through that number there. This dotted line here, x equals 1, is what's called the axis of symmetry, that the parabola is symmetrical about that line. So the axis of symmetry is the equation of the line. It's a vertical line, x equals 1. So try to remember that this isn't just an x value, it's the equation of a line that passes through 1. Now, the last two questions are to find the domain and the range, and the domain of a parabola is always all real numbers no matter what. It turns out that since the definition of domain is the set of x values that you can plug in and get valid y values out, and basically there is nothing to restrict. So normally we restrict any time you'd be dividing by 0 or taking the square root of a negative. But there's no division by 0 here. There's not even the denominator at all to look at, so you would never be dividing by 0. And there's no square root, so you would never have the square root of a negative. Basically, any number you plug in for x, you can square it, you can multiply by negative 3, you can take any number and multiply by 6, and then you would just have 3 numbers being added together. Nothing goes wrong in that process. The domain would then be all real numbers, and to say all real numbers in an equality notation, you would say that x is bigger than negative infinity, and at the same time x is less than infinity, and that's just a fancy way of saying everything works. If you wanted to combine this into a compound inequality, that would look like this, and it would say the same thing as above, that x is less than infinity and at the same time bigger than negative infinity. And this would be writing my answer in inequality notation. To write it in interval notation, it would look just like this except without the symbols here. You'd have negative infinity, you'd put a comma here and then a positive infinity, and the idea is, since we know the domain is always the set of input variables, and it was given in the beginning that my input variable is x, we need not write the variable x. It's assumed that we're talking about the interval for x values between negative infinity and infinity. So that would be my answer for the domain. Now that I've cleared that, we can go on to the range. Now the range of a parabola depends on the vertex. The y values can go down as low as you want. So this graph goes down to negative infinity. It is not the case that the parabola goes up forever. In fact, the highest that I can possibly reach on this parabola was my vertex that had a y value of 14. So my highest point there had a y value of 14. So my range is that my y values are less than 14. And I should include 14 because remember that's part of the range. In fact, 1 is in my domain. And we plugged 1 in earlier in the video, we got out 14. So the parabola actually takes on that point. So we should include the 14. So my range in inequality notation would be simply that our y values are less than or equal to 14. And in interval notation, then, we would say that the y values go down as low as negative infinity. You don't actually reach it, so we put a parenthesis, comma. The highest that my y values would be 14. And because we want to include the 14, it was part of my range, because 1 was part of my domain, we include the 14 in interval notation by putting a bracket. And basically, that finishes the problem.